a plexus sphere and ring to our Earth object. In this movie, we'll give them a little pop by animating them. You can either continue working from your previous file, or load the provided Mash UI Part 3 Start, provided in the link in the description. Animating in Maya is much like animating in traditional hand animation. You start by snapshotting a scene in a certain state at one point in time, known as keyframing, then snapshot a different state at a later point in time, letting Maya fill in everything in between. Maya keeps track of time via the time slider, which is divided into frames rather than seconds. By default, 24 frames makes up 1 second, though this is customizable. For this tutorial, we'll leave it as is. Let's start with a simple animation of rotating the Earth. Like the ring in the previous movie, we need to add a transform node if we want to transform the Earth, so select the Mash Earth object and create one. Notice that if you alter the Y rotation of this node, it spins the Earth. So to animate the Earth spinning, we just need to set keyframes on this value. Go to frame 1 in the time slider, then right-click the Y rotation value. Select Set Key. The attribute turns red and a red line is drawn in the time slider to indicate that its state has been captured. Next, go to frame 120. If your time slider doesn't go that far, you can change it via the values on the far right side under the time slider. Set the Y value to 180 and set another key. Now if you play the scene, you can see that the Earth spins 180 degrees in 5 seconds. However, notice how it starts off spinning slow, then revs up, before slowing down again near the end. This ease-in, ease-out behavior isn't really what we want for this particular animation. To fix this, we'll use the graph editor found in the Windows Animation Editors section. The graph is a visual representation of the attribute value over time. First, press the F key to frame the graph and make it easier to see. Notice how the graph moves up, representing the increasing value of the rotation. However, these curved ends are the reason for its slow start and finish. To fix that, select both ends and click the Linear Tangents button. This straightens them out. Now if you go back and replay the scene, you can see that the Earth spins consistently. While we're here, add a very minor rotation on the x-axis, just so the Earth isn't completely straight. We don't need to animate this, it's just to add a bit of variation. Now using the exact same process, add transform nodes to the bolts and plexus layers as well, to make them spin along with the globe. With all the globe elements spinning in tune, let's animate the ring next. Recalling from the previous tutorial, we already created a transform node for the ring, which we can reuse. However, notice that if you try to spin it using the Y rotation, the ring actually wobbles. This is because it's taking our other rotations into account, so zero them out for now. Also, rather than spinning from 0 to 180, let's spin the ring from 0 to negative 180, so it runs counter to the Earth. And again use the graph editor to ensure it spins at a constant rate. To add the ring's lean back, go to Mash Ring and add another transform node. Input your previous lean values into this. Now the ring spins correctly and still leans nicely. However, we can do even more with this. Let's also animate it pulsing by using the replicator node's random strength attribute. Start by going to frame 1 in the time slider, then set a key on the current random strength value. Next, go to frame 12. Decrease the random strength value and set another key. Now if you drag the time slider between frames 1 and 12, you can see how the ring shrinks randomly. Go to frame 24 and increase the random strength value back to the same number as frame 1. This sets up a cycle of the replicants decreasing and then increasing again. However, unlike our spin animations, this one doesn't fill all 120 frames. We could manually key the value up and down over and over, or we can once again use the graph editor to repeat it automatically. First, select the Mash Ring Replicator's random envelope curve in the list to isolate it. Then press the F key to frame the graph. Notice that this time the graph is a wave, representing the way the random strength decreases and increases. Go to View Infinity to see what the rest of the time slider looks like. Notice that after our keyframes, the graph levels off, indicating that random strength remains a single value. To change this, select the curve and go to Curves, Post-Infinity, Cycle, to make the curve repeat itself forever. Judging by our new graph, the value should now constantly go up and down. And if you play the scene, you can see that is indeed the case. Finally, we can animate the ring being created. Rather than frame 1, this time start at frame 12. Go to the Distribute tab and set step strength to 0, then set a key. If we want the ring creation to happen over 2 seconds, then we'll need to set our next key at frame 60. Go to frame 60 and set step strength to -1, then set another key. This will ensure the ring is created in the same direction that it's spinning. And like our various spin animations, we don't want the ring creation to ease in, ease out either, so return to the graph editor and make all the tangents linear. Our globe looks a lot livelier now, thanks to all this animation. In the next movie, we'll show you how to create a rotating HUD element that's constrained to the camera. In this movie, we animated our various MASH networks using keyframes. In this movie, we'll create an animated HUD element that follows the camera. You can either continue working from your previous file, or load the provided MASH UI Part 4 Start, provided in the link in the description. We're going to create 4 different types of HUD objects, starting with the simple spinning grid in the top left. To start, create a new cube and rename it HUD Cube. And use the attribute editor to reduce the scale to 0.5 in all axes. This is the base object we'll use for all our HUD MASH effects. Create a new MASH network from this cube and name the network MASH HUD Grid. We'll use this nomenclature for all our HUD objects to make the outliner clearer. Don't forget to rename the repro mesh to match. The easiest way to create a grid is to use the appropriate distribution. So go to the Network's Distribute tab and set the distribution type to Grid. Scroll down to the Grid Settings section and set the number of points in X, Y, and Z to 3, 5, and 5 respectively. This will create 3 rows of a 5x5 grid. Let's also reduce the distances in X, Y, and Z to 3, so the gaps aren't so wide. With our grid finished, the next thing we'll want to do is animate it. Since we want the grid to rotate, let's add a transform node to the network. Just like the previous movie, you can change the rotation values here to rotate the grid. However, it's kind of a pain to rotate it by putting manual values in like this. Instead, let's use a controller object to help us. This is somewhat similar to the Earth sphere we've been using for our globe. While we could connect an existing object, we don't really have anything appropriate to use yet. So right-click the controller null field and create a new one. Maya creates this small plus-shaped object called a locator that is connected to our transform node. Notice that now you can use the rotate tool to manipulate the values much more interactively. Unfortunately, something's wrong. Notice that the grid is rotating unevenly on its base. We'd prefer that it rotate from its center. This is happening because our grid distribution only builds the grid upward. To fix this, we'll need to offset the grid first, then rotate it. Set all your rotations back to 0, then translate the locator down to -1.5. Use the attribute editor to be precise, then hide the control locator by pressing Ctrl H since we don't want to accidentally tweak it again. Now that the grid is centered on the origin, go back to the waiter node and create a second transform node. This one will act on top of the one we used to offset. Just like before, create a locator to control it. Now if you try rotating, the grid rotates around the center just like we wanted. Next, let's animate the spin using what we learned in the previous tutorial. Go to frame 1 in the time slider, then set whatever starting rotation you'd like for your grid while pointing the camera down the Z-axis. In the Attribute Editor's Transform tab, right-click the Rotate attribute and set a key. Now go to frame 120. Let's say we want this grid to rotate 3 times on the Z-axis. A full rotation is 360 degrees, so set the value to 1080, and right-click Rotate to set another key. Once that's done, press play to watch the animation. The initial animation is okay, but it's spinning a little fast. Go back to frame 120. Instead of 3 times, let's make the grid only spin once. Let's also change the direction of the spin by inverting the number, so set it to -360. Notice the Z-axis field changes color to indicate that the value shown is not keyed anymore. Right-click the Rotate attribute and key the frame again. That's much better. To give it even more variation, you can also try adding a secondary spin to the X-axis. This time we'll only give it a half turn in those same 5 seconds. And like the various spin animations in the previous tutorial, we don't want this ease in, ease out behavior, so use the graph editor to make all its tangents linear. Now that the spinning grid is finished, we just need to position and fix it to the camera. Rather than use the default camera, let's create a new one strictly for this purpose by going to Create, Cameras, Camera. Rename it HUD Camera. Now if you go to Panels, Perspective, you'll see that in addition to your default perspective camera, there's also the new HUD camera here. You can use this menu to switch the camera you're looking through at any time. Look through the HUD camera, then pull it back until it frames the globe. Try to keep it looking down the Z-axis, since that's what we oriented our rotating cube to. Once you've framed the globe, there's a couple more things to do before positioning our element. Go to View, Camera Settings, and turn on Resolution Gate. This will show us the borders of our camera resolution, which will make it a lot easier to position the grid correctly. Then go to the HUD Camera tab and click Presets. Save the current transforms as a new preset called HUD Camera Default. Now we can return the camera to this position whenever we need to. With that done, we're now ready to place our UI element. Add another transform node to your Mesh HUD grid network. As before, create a controller for it. This is the transform we will use for placement. The easiest way to do this is via the ForeView, which you can open by clicking the ForeView icon on the left side under the toolbar. This simultaneously opens up a top, front, side, and perspective view of your scene. Just like you did before, change the perspective view to your HUD camera. Unfortunately, the outliner has disappeared due to our use of the ForeView, so open it in a separate window by going to Windows, Outliner. Select the grid's controller, then use the Move tool to translate it towards the camera in the top view. You'll notice the grid get bigger in your HUD camera view. When it's the desired size, indicating a good distance from the camera, use the HUD camera view to position it in the top left. You can then expand the HUD camera view again by placing your mouse cursor in that view and pressing spacebar. We're almost done, but notice if you try to zoom in and out of the scene, the grid doesn't follow. That's because we haven't yet attached it to the camera. This is easy to do though. In the outliner, select the HUD camera and then shift select the grid control locator. Use the drop-down here to change to the animation menu set. This changes the available menus at the top to those more suited for animation. Now go to Constrain, Parent. This tells Maya to constrain the grid to the camera so that they always transform together. Make sure the Maintain Offset option is turned on. Now if you try zooming or moving the camera, you can see that the grid follows along. As a final bit of cleanup, select all 3 transform control locators in the outliner and press Ctrl-G to group them together. Rename the group Mesh HUD Grid Control Group, and then use Ctrl-H to hide this group so the locators don't appear in the workspace. This way they won't clutter up the workspace or move accidentally. In the next movie, we'll use the skills you've developed in this one to create the other 3 HUD elements.